Hello, in this video, we'll talk about how the data can be processed and prepared for analytics. Our textbook mentions some characteristics which define the readiness of data for analytic study. Let's look at some of these. First of all, we have data source reliability. Data source reliability refers to the originality and the appropriateness of the storage medium where the data is obtained. It answers the questions such as, do we have the right confidence and belief in this data source? Are we using the data that is coming from the right source? You should always look for the original source of data to avoid any misrepresentation. Every time someone moves the data and takes it to a different location, it may be transformed or reformatted, which may lead to inaccuracies. Let's take an example of looking at customers' billing information. You may like to look for that data in a central customer management system or wherever is the central repository for storing the customer data, because that data may be regularly updated. We should not take customers' data, let's say, from a copy of the data or the contact list of the last marketing promotion. That may be outdated data, that may not be the most correct or updated version of the data. Going to the data content accuracy. So this is different from data reliability. Reliability refers to the source of the data, and content accuracy refers to how accurate or how correct the data is, and whether this data is a good match for the analytics problem. The question we are answering here is, do we have the right data for the job? For examples, customers' contact information recorded within a database should be same as what they said it was. So if the contact information is not correct, then we are not using the correct data or the accurate data. The next characteristic or metric is data accessibility. What it means is that data is easily and readily available. The question we are asking is, can we easily get to the data when we need it? The next metric is data security and data privacy. It means that the data is secured and only those people who have authorization to access it can access it, and others who are not authorized to access it should not be able to access it. So preventing any unauthorized access to data. Data richness means that all the required data elements that you need for the analysis are included in the data. The available variables basically should portray a rich enough dimensionality of the underlying subject matter. It should cover enough of the subject matter for an accurate and worthy analytic study. Data consistency is again a very important metric. What that means is that the data are accurately collected and combined or merged. Let's say if you are taking data from multiple sources, or if you are combining them, if you have multiple copies of the same data, we would want all of these data about the same topic or the same area to agree with each other and not have one document say something and another document say something else. So we want that data across different copies or across different versions should be consistent, and it should represent the same picture. Data currency or data timeliness means that the data should be up to date or as recent or new it needs to be for a given analytics model. It doesn't mean that every piece of data needs to be updated in real time or every second. Let's say if you want to conduct a quarterly analysis on sales, then your data must be updated at least every quarter. So timeliness doesn't mean that it has to be updated every second. It just means for the analysis, the data is recent. Data granularity requires that the data is defined at the lowest level required for the analysis. It means that if we need to know the performance of one student in a classroom, you need to have individual level grades. But let's say if you need to know only the average grade of the class, then maybe your data could be aggregated at the level of the class. So depending on the type of analysis that you are conducting, that will determine the level of abstraction or aggregation of your data. Data validity and data relevance are related. Data validity is the term used to describe whether there is a match or mismatch between the actual data and the expected value of the data in a given variable. The acceptable values or value ranges for each data element must be defined. And accordingly, we'll see whether it matches the expected value or not. For example, if you are entering the age of a person, then the acceptable values are either 0 or higher positive numbers. Negative numbers or entering alphanumeric data may not be valid for this. Data relevance means that the variables in the data set are all relevant to the study being conducted. It means that the data is usable for this analysis. Now we know the different metrics of preparing the data. Let's take some time to understand the taxonomy of data and get familiar with some of the important terms here. We already know that the data refers to a collection of facts. Usually, data is obtained as a result of experiment, maybe observation, transaction, experiences, and a variety of other ways. Data can be classified as structured data or unstructured data and semi-structured data. Unstructured or semi-structured data is composed of any combination of textual, imagery, voice, web content, etc. Traditional methods of data analysis were not suitable for unstructured or semi-structured data. We will learn more about these two data types and how to analyze them when we go to text mining and web mining. For now, let's deal with structured data, which is what we will be looking for a few weeks now. Structured data is what data mining algorithms use and can be classified as categorical or numerical. The categorical data can be subdivided into nominal data or ordinal data, whereas numerical data can be subdivided into intervals or ratio. Categorical data represents labels of multiple classes used to divide a variable into specific groups. Categorical data can also be called as grouping data. Examples are race, sex, age groups, education level. Now you can represent these category or categorical data either as text or numbers. Even if you represent these as numbers, they are nothing more than symbols and you cannot do any kind of mathematical operations with categorical data. It would not make any sense for us to either add these numbers or subtract these, even if we represent categorical data as numbers. For example, zip code. Zip code is just categorical data. It's a label, looks like number, but does it make sense for us to add a zip code to another or subtract from another? Similarly, your SSN or phone numbers. So they are all categorical data. Now, categorical data, like we said, can be nominal or ordinal. Nominal data contains measurement of simple codes assigned to objects as labels. So nominal data are just like labels. Your zip code, your SSN, phone number are all examples of nominal data. You can't say if one is bigger than the other or one of these comes before the other. There is no inherent ordering in the data. For example, name of the states. If you say North Carolina is one state and then, we have other states. Other examples include like gender, relationship status, ethnicity, degree majors. We can't say if a CIS major is better than arts major or any other major. So that's nominal data. Then we get to ordinal data. Again, ordinal data is categorical data, so it is labels. However, they also have an inherent rank order among it. So you will be able to rank ordinal data. Examples include age group, education level, name of the month, days of the week. So You would see in age group, you can say, for example, there is some order. So a child is younger than an elderly person. Or you can say January comes before February. Similarly, there is an order. Now again, with ordinal data, even if you assign numbers for it, let's say you say January is 1, February is 2, and so on and so forth, doesn't make any sense for us to do mathematical calculations on it. Now, let's go to the other type of structured data, which is numerical data. On the numerical data side, we have interval and ratio. And depending on which type of data it is, we may be able to perform allowed mathematical operations on these. Interval data are variables that can be measured in interval scales. A common example is measuring temperature on Celsius scale. It makes sense to add or subtract these values, but does not make any sense to perform division or percentages because there is no absolute zero. Ratio data is what we commonly find around us in physical sciences, engineering, businesses. For example, mass, length, time are all examples of ratio. In the context of business, employee salary, sales, profit can also be examples of ratio data. It makes sense to calculate ratio, perform divisions or percentage, as well as there is the presence of a non-arbitrary zero value with ratio data. Other types of data include textual, multimedia, XML. So for these type of data, we first need to convert these into some kind of either categorical or numerical values before we can process them using analytics methods. Some predictive analytics, for example, data mining methods and machine learning algorithms, are very selective about the type of data that they will handle. For these reasons, we need to pre-process the data before we can run any analytics. We will learn about pre-processing of data in the next video.